So mine's a little different. You can see it's kind of like, this is the classic one. So when I say place your compass point, for your compass point is that little clear thing you can take and kind of, seems like the swivel that I did. So that's your compass point, really. So whereas mine is actually literally a point, yours is just this little, okay, you stop thinking about it. So yours is literally this little clear circle, and you're going to center that on the point, okay? And then you'll see this little slider, okay? So we got this little slider here, and this is what decides how narrow or how wide you're going to pull out. So as I'm adjusting the little pencil point here is what this is, you're going to be adjusting this. And what you'll notice on here is there's two different holes. And so if you're going to do two different arcs, swing arcs of different distances from wherever the compass point is, you can do that by using the two different holes there and not have to adjust this. Now, you should be able to turn the dial on there so that it is parallel to the ruler. So it'll go from perpendicular to the ruler to parallel to the ruler. And when you do that, it locks it in place, which is really nice. There's no slipping. That's the problem with these type. I don't know if you've ever used these type of compasses. They're really, once they get kind of loose, it's really frustrating to work with them. So you'll have to bear with me on this. I'm not real good with this virtual one, but we'll go for it and try it, and I'm sure you'll be patient with me. And I will help you to learn how to use these. I'm actually better at these than I am with this. We'll see. We'll see how it goes. But you have one here, and thanks for the vote of confidence. So I'm going to show you, there's just a couple definitions here. Like I said, the purpose of constructions is really to foster your understanding of definitions of geometry. I think we did. Oh, is there one more to do? Okay. So one more to do from 1.5?
And there's a back.
Okay. Yes, we'll finish the 1.5. So perpendicular bisector is a segment, ray, or line that hits a segment at its midpoint. So perpendicular bisector is something that splits a line segment in half. Okay, it'll hit it right in the middle, and I'm going to show you how to do that with the compass. Okay, so we'll learn how to do that with the compass. And then we're also going to do the same thing with an angle bisector.
It's not out here.
What's that?
So,
Okay. So you'll have to write it in maybe. So perpendicular bisector is a segment, ray, line, etc. that hits a segment at its midpoint. You're going to have a picture of that. We're going to do that right here, right down here. And then an angle bisector is a ray that cuts an angle in half. So it's pretty easy to construct a 90-degree angle. As a matter of fact, a perpendicular bisector creates a 90-degree angle. So if I combine perpendicular bisector with the angle bisector construction, I can create a 90 and then a 45. You with me? Like if I take a 90, cut it in half using the compass, I'll have a pretty accurate 45-degree angle, okay, depending on how accurate I am with my compass, right? And then if I take the 45 and split it in half, I could create a 22.5-degree angle. And so you can create different size angles that way. And then you can actually construct even different geometric shapes, and they will be pretty accurate in terms of the lengths of their sides. Like you could construct a square where the lengths of the sides are all the same. You know, they're pretty accurately, and all the angles are 90s without drawing it freehand. You see how much you'll be off freehand unless you use some kind of grid lines or construction on it. All right, so the first thing you need to be able to do is just copy a segment, and we're going to copy it not by measuring it. Okay, we're not doing any measuring. So we're going to copy it by using our tool here, the compass. So first thing I'm going to do, I don't think you have, you can just actually watch on this, or maybe if you have some scratch paper, you could do this. I would have some scratch paper out. You can do a couple constructions on there. You put the step process on there, so you don't have to write anything down. You're just going to do the construction working. But if you need any scratch paper, I've got a little bit up by the pencil sharpener another time. Okay. So you guys can take out just a piece of scratch paper. It could be white paper, line paper. That would work. Homework task back would work. And what I'd like you to do is, with your straight edge, you don't need to pay attention to how long it is on here in centimeters or inches. Just draw on there a line segment, just like that. Not any particular length, just a line segment like that. Draw it on your paper. Okay. And what we're going to do,
Scratch paper.
on your scratch paper, on your scratch paper. We're going to do 2 constructions on your note packet, okay? And they're going to be the perpendicular segment bisector and then the angle bisector, and that's it. All the other stuff you're going to just, if you could just do it on scratch paper just for practice, and see if you can do this. Then I'll have some different construction problems for you to try. Okay? And then I'll come around and help you. You can get help for some next year. So here's the idea. We want to copy a segment that's exactly the same length. Okay. So typically what we'll do is take and just draw a generic segment that's longer than the one that I just drew, that I'm going to copy. And the reason for that is that I'm going to change this to black here. I'm going to take my compass and I'm going to use my compass to measure the length of the original segment as best I can. And so what I'll be doing then is and for you guys on yours, you're going to take and place this circular clear point right on here, on this, where I have my compass point. You'll have your circular clear point. And then what you're going to do is stretch this out so that one of these holes, either the near one or the far one, matches up to the end point of the segment that you just drew. And then you can tighten it up. So if it's about that long, if it were that long from the open circle to the first point, you would just tighten it and leave it there. And then what you're going to do is take your compass. I'm going to take mine here, move my compass over here, place my compass point. Tricky here. There, that's close enough. So my compass point on the end of the segment that I drew that's longer than my original one. And all I'm going to do is swing a little arc here. And now what I've done, if I pull this away here, is I've created a segment, and I'll highlight it here. Highlight it here. My segment from here to here is exactly the same length as this segment from here to here, well, aside from human error, of course. But that's copying a segment. And so if you can do that, if you can copy a segment, then you can start to draw or construct, I should say, not draw, construct fairly accurately things like an equilateral triangle, or a square, or a regular pentagon, regular hexagon, that type of thing. Okay. So that's copying a segment. Any questions on that? So if I say, I want you to create a square whose all 4 side lengths are the same length as this segment that I gave you, then you could do that. Okay. And it's going to be a combination of that and perpendicular bisector construction. Okay, go back to your packet. So in your packets, on that top one, we're going to do a bisector together. So once again, you just need to be able to do the bisector. You need to have a line segment on there. So if you already drew one, that's awesome. That's probably great. So I think I said to label it A and then B. So let me go ahead and do that. So we're just going to draw somewhere on here a line segment, and we're going to label it A, B. So we got A over here, B over here. And what we're going to do is we're going to find the midpoint of that segment AB and also create a 90-degree angle. Okay, so perpendicular means 90-degree angle. Bisector means splitting that segment in half. Okay. So the way we do that with our compass here, you place your compass point at A. Place your compass point at A, and then this is, I'll let you do that first. So place your compass point at A, and then you're going to have to, on your compasses, decide on which little hole you're going to use on there. But the key point here is that you have to stretch out your compass so that it is longer than half segment AB. So it needs to be more than half of segment AB. And the reason for that is that if I go to, I'm going to go swing some arcs above and below this line, and then I'm going to go to the other side to B and do the same thing. And if the arcs don't intersect, I won't be able to connect a line segment that splits it in half. So it's really important that you stretch this out so that it is more than half the length of AB. Okay. What's that?
We don't know what that is.
Well, we don't know exactly what it is, but I think you could look at it and tell me that you stretch your compass out more than half, right? You should be able to eyeball it and say, like here, I'm clearly more than half. I'm almost to B. Okay. So right here, what you're going to do then with your compass is you're going to swing a little arc up here, like that. And it doesn't matter what the length is of it, really. If you wanted to, you could, and some students will do this, just swing a full little half circle here, right, like that, if you want to. It just makes it a little messier. It's a little cleaner if you do swing an arc up here, and then you just swivel your compass down over here and then swing another arc here. So, but you can swing a full half circle, and that'll work just fine. And then what I'm going to do is put my compass point on the other end here. So place your compass point on the other end. So on B, you'll have to just flip it around. Don't change anything on your arc. Your arc needs to stay the same length. So whatever you set your arc on, it needs to be exactly the same. If you've loosened it and changed it, go back over here. Just a minute here. You want to go back over here and measure the distance from A to the arc again. Make sure it matches up. You can go back over here, maybe. Okay, and then place your compass point here. Okay. What's up, Eva? Another one? Is that not working? So your brain. See if I can fix it. That's too bad. This one I think was walking. You can tell it's way stiffer. All right, so swing. You can swing a little arc here if you want, guys. Just swing a little arc and then skip up to here and swing another, or like this. That just makes it cleaner, a little cleaner when you don't have all this in between. Or you can swing just a whole half circle. So sometimes it actually helps, I think, a lot of students to have this picture in their mind. Like a perpendicular bisector is a line segment, and there's like a half circle on one side and a half circle on the other, and where those half circles intersect is where you're going to connect the two dots. So do you see the intersection up here? And an intersection down here? And then you can start to see what's happening, I think. If I place a dot right here, this is where the human error comes in, is when I'm placing those dots. Like what I'm doing with the straight edge or compass is pretty solid. But as soon as I start putting dots in there, it is, I know. That's what I'm saying. That's why I said that. But that's okay. I am. Let's see if I can get this thing right. Okay, then you take your trusty straight edge. I'm going to do the best I can on this. So take your straight edge, and then you're going to draw in. Oops. Darn it. And then draw in that segment. Here we go. We'll get it. We'll get it here. This just gives you guys time. There we go. So I drew in my segment. And that segment is the perpendicular bisector of AB. So a couple things happening here. One is this is 90. Whoops. This is 90 right here. And two, this segment, we can call this, I think I said to call this M right here for midpoint. But AM and MB are congruent. So AM and MB are congruent. And so that's actually the basis for being able to draw a square. Right? If I could do a perpendicular bisector, and then I'd have to do a copy of the segment. I might have to extend this out a little bit, but copy the segment, I could get a congruent side here, a 90 here, another congruent side here. And you might have to think about how you could get the other two sides for this square. I'm asking you to construct a square from the start of this. You have to think about that. Well, problem solving is pretty good. So that's the perpendicular segment bisector construction. So once again, you have a segment, you stick your compass point at one endpoint, swing an arc, go to the other endpoint, swing another arc where the arcs intersect. If you connect those dots, it will make your perpendicular bisector. Okay? And all the instructions are on there. All right, angle bisector. So here's what I'd like you to do for the angle bisector. Take your straight edge, and we're going to just draw an acute angle if you could. Draw an acute angle. There we go. I'll draw an acute angle. There's one piece. Other piece. There. That out. So draw an acute angle, not like that. Pull this back down here. You're going to take your compass and place the compass point right there on the vertex. And you may not need to change your locked position on your compass up and down. Probably just leave it there. One thing with the angle bisector is you're going to swing an arc through this thing. You don't want it to be too close to the vertex. So maybe use the hole that's on the far side of the locker. But what needs to happen when you do swing it, you might have to adjust the locker. It'll give you a minute to do that. But when you swing your arc, it needs to go through and hit both sides of your angle. Okay? If it doesn't touch both sides of the angle, you won't have a reference point for the next two arcs we're going to do. But the angle bisector starts by drawing an angle, and it doesn't have to be acute. It's just kind of easier with an acute angle for this first one. So draw an acute angle, we swing an arc there, and then let's do that first. Make sure that arc intersects the angle both places. And you really have to watch what I'm going to do next to get the next two arcs. So the idea is this: I need to get two crisscrossing arcs somewhere out here in the interior of the angle that are an equal distance from each side of the angle. So the idea, it works like this. You probably can just leave your compass set where it is, probably. As long as it's such that when you go out, you're going to place your compass point right here where it intersects one part of the angle, and you're going to swing an arc. And then you're going to take your compass to the other place where the original arc intersected, and you're going to swing another arc from there. And so you kind of can picture in your mind, hopefully, the angle bisector construction has an original arc, and then it has two crisscrossing arcs out in the interior that are equally distant from where the original arc hit the side. Okay, so see where my compass point is right here? And you'll know right away if you've done it. correctly, because if I connect, this is always tricky with the digital ruler. So if I connect, pretty good right there. If I connect the vertex through where those two arcs crisscross, it should split the angle in half. Oops. Didn't lock in. There it is. Didn't quite lock in that time, so it's not a perfectly straight line, but you can see the two angles. Highlight them here. We have an angle right here, and then an angle right here. Above and below that black line, and those two angles are congruent, if I've done it correctly. So that's the angle bisector. So if I told you, this angle, if I handed you, say, a 60-degree angle, this angle bisector would give you 2/3. Okay? Or if I constructed a 90 and I split this 90 in half up here, and I could do an angle bisector up here, I'd have a 245. Those are the only two you really need to know well. So I'm going to give you a few problems to try. Okay, go ahead.